What's the title?
Okay, so we're looking at solving 1- and 2-step equations today in algebra. Now for this, having a method to do this is absolutely key. So that means we have to learn a method, or maybe improve our method, or work on our method that we have already. So an example of one step would be a question such as this. So x plus 4 is 7. And you want to solve this. You want to crack the code or figure out the puzzle. What could x be, or what is x? I think it can only be one number. What is that number? Yeah. So it's some number plus 4 is 7. So some people are typing in the chat there. 3 plus 4 is 7. And of course, 3 is the only number it could be. 3 plus 4 is 7. So we don't need to do a method. We'll just get this one straight away. Yeah. So we need to learn the method of perhaps ones that you can do in your head, so that when we get to a more complicated question, so you can stop, you can just stop taking notes for a second as we very quickly look at a more complicated question. An example of which it perhaps wouldn't be immediately obvious what the answer is here. And if you're stuck with just guessing an answer based on you just know it's 3, for instance, the one above, and when we get to this stage, if we've no method, we get stuck and we go, oh, well, I really don't know, because the answer could be a fraction, could be a really awkward decimal. So that is why we need a method to eventually get to solve questions like this, which we will in this unit. But we go back to this. We're not going to get to that until, well, another week or two. So we have to go back to this and we have to figure out the method. Now, Ethan has a method suggested, and he's writing away. So there's 2 steps to the method. So make sure you take today's notes down, because it's very crucial, and you're going to be using this method perhaps for the rest of your entire mathematical career. So there's 2 steps. First step is do the opposite. And the second step is to balance. And that's it. There's our 2-step. Doesn't make much sense yet, but it will in a second. All right. So the answer to this equation needs to look like x equals something. At the moment, I have x plus 4 equals something. But I don't want the plus 4. So to get rid of this plus 4, I need to get rid of the plus 4. I need to do the opposite thing to it. So if I subtract 4 from it underneath, that will disappear. And I'd be left with, well, plus 4 take away 4 disappears, and I'm just left with x on this side. But what I haven't done is balance the equation. If I do anything to one side, now when I say side, I mean the equal sign is like a barrier here. So I've done minus 4 to one side of the equation. Well, I need to do it to the opposite side as well, otherwise I've changed the equation. So that's what I mean is do the opposite. So that would be subtracting 4 instead of adding 4, gets rid of it. But I need to balance the equation by leveling out the equation. Otherwise, I have tipped the equation. So if you think of it as a balancing point, if I subtract 4 from one side, I've all of a sudden made the other side bigger. So I need to subtract 4 from both sides, and it's still balanced. It's still the same equation. Now, how does this help us? Well, watch what happens. X is still on this side, the left-hand side, so the equal sign is like a barrier. X is still over here, because it's just X, nothing's done to it. But plus 4 take away 4 is nothing. They just cancel each other out. The equal sign is still there. And 7 take away 4 is 3, which is the answer we want. So this equal sign is like the balance that we have to make sure that we don't unbalance the equation once we do the opposite thing. Now, of course, you're telling me that this is way too complicated for a question that we knew the answer to at the start. But remember, our goal is to solve equations like the one I wrote a second ago by using a method. We need a method. Okay, so that's our first example. Let's do another question. Another one-step question. So the question will usually say, just solve 2x equals 8. So there's another algebraic equation. This time the operation is 2, it's 4, it's 2 times something equals 8. So, but let's do my method here. 2 times something equals 8. So I need to do the opposite to get rid of this 2. What's the opposite to multiplying by 2? Dividing by 2. How do I write that? Well, I just divide this side by 2, so that's division, and divide this side by 2. So I balanced the equation. I've done the opposite to get rid of the number. So notice the number here was 4, and I got rid of it by subtracting 4. The number here is 2. I get rid of it by dividing 2, because that's 2 times. Now what happens? 2 divides into 2 once. So you can simplify it down, and it's just x left behind. And 2 divides into 8 4 times. And that's my answer. Let's do one more of these one-step equations. What happens if there's division in the question? X divided by 7 is 3. So I go to my method again. Do the opposite to get rid of that 7. And then balance the equation. So what's the opposite to dividing by 7? Dividing by 7, the opposite to that is multiplying by 7. So I can put a little multiply by 7 up here. And then, but if I'd done it to one side, I've unbalanced it. Remember, if I only multiply one side by 7, I made it super heavy. I've added loads of 7s to it. So I need to do the same to the other side. Multiply this side by 7. All of a sudden, you balance it out. So do the opposite and then balance. Now 7 divides into 7 once, so it disappears. So what you notice is that once I've done that opposite thing, something will cancel out. The number that you wanted to disappear will cancel out. On this side, I'm just left with that x, which is what I want. And 3 times 7 is 21, which a number of people have put in the chat. Well done. Okay, we'll box around the answer just to make sure. So x is 21. All right, so that would be a one-step. Let's move on to 2 steps. Okay, so make sure you're taking notes. So a two-step equation, I'm going to give you a question example. Okay, 2x minus 7 equals 13. Now I want you to try that one first, and I'll give you the method in a second. See, can you do it first, rough or in your head? All right, so a few people have put in 10 as an answer. Let's see if you're right. We got to do the method. Remember, method, every time do the opposite and then balance. So watch me do the opposite. So I need to get rid of 7 and 2. I can pick either of them to get rid of first. Usually if I can add or subtract, I do it first. Oh, sorry, I have someone here in the house.
Can I use this one?
Yeah. So 2x times 2 times x is equal to 20 now because I've added 7 to both sides. Now, to get rid of the 2 now, I know already 2 times 10 is 20. I know already that. I know the answer is 10, but let's just do it using the method. Divide by 2 is the opposite to multiplying by 2. Divide both sides by 2. Because the 2 divides into 2, you're just left with x. 2 divides into 20 10 times, and my answer is 10. Okay, let's do another example. Okay, so I don't see many people with that.
Okay.
With that one in the answer to that one yet in the chat. This is where the method is absolutely crucial. The answer to this is a fraction, so it makes this really difficult. That's why we use the method. 84 is Louis' guess. It's not right. Okay, let's get to the method. So if I can add or subtract anything first, I can do that. So this is going to be the same first step as this one. because I need to get rid of this subtracting of 7 and this dividing of 3. So I already know I'm going to have to add 7 and multiply by 3. The opposite things, because I'm trying to get x on its own. So the opposite to subtracting 7, add 7 to both sides. Draw a line underneath. So remember, when I say sides, I mean the equal sign. Okay. So plus 7 take away 7, well, that disappears. That's my whole key. That's the first step. That's why it's called 2 steps. 1 step, then 2 step. I've done 1 step. I've got rid of one number, the 7, but now I need to get rid of the second number, 3. But let's get an answer to this line first. X divided by 3 is still x divided by 3. That's now gone. The equal sign is here. 20 plus 7 is 28. Okay, so 20 plus 7 is 28. Now, I need to get rid of dividing by 3. Oh, Louis, you might have been right. I need to get rid of dividing by 3. What's the opposite to dividing by 3? The opposite would be to multiply by 3. Both sides. So 3 divides into 3 once. So that just cancels out to simplify that fraction. So now we're just left with x equals 28 multiplied by 3. So his answer wasn't a fraction. Sorry, I had the wrong thing in my head. 3 times 28 is the answer Louis gave. 3 times 20 is 60, and 3 times 8 is 24. So you can do that in the calculator if you're not entirely sure. That's a tricky one to finish with. But 84. It would have been a while waiting to guess 84. Good work, Louis. All right, I'm going to do one more of these 2-step equations. What happens if the x is not on the left side of the equals? It's on the right-hand side of the equals. Well, we're going to find out now. That looks a bit different. Okay, I'll give you a second if you want to try that one before me. Charlie thinks it's 12 and a half. So remember, you can always test your answer by redoing it. 17 has to equal 8, take away 2 times something. And if you have an answer like 12, 2 times 12 is going to be 24. So 8 take away 24 is not going to give positive 17. Okay, so now I need to get rid of the 8 and the negative 2 on this side of the equal sign. So a lot of 12.5s coming in. Okay. Well, I think you've made a crucial error at the start of this problem. That's 8. It's not negative 8. This is negative 2 times x. This is positive 8. So if I want to get rid of positive 8, there's no sign in front of it. It's just always the sign in front, not the sign after it. So that's positive 8. So if I want to get rid of positive 8, I need to subtract 8 from both sides. That's my first step. So if there's no sign, same way as this 17 is positive 17, you're presuming it's positive if there's no sign in front of it. So we presume this 8 is positive with no sign in front of it. This is a negative 2 times x. All right. So, yes, Priyanka.
Is it the same if you do 8 minus 2x equals 17?
Yes. Yeah. So you could put the equals because it equals 17 either way. Yeah. 8 take away 8 then disappears. That's great. 17 take away 8 gives 9. So I saw someone with 4.5 as an answer. Maybe that's the answer. Anyway, that's a negative 2x. Negative 2x. So Charlie, are you sure it's positive 4.5? Negative 2 times x. So what do I need to divide by? Well, if it's a negative 2, I need to divide by negative 2. I'm doing the opposite. That's negative 2 times x, so I need to do the opposite. Negative divide by negative 2. So if I divided this side by negative 2, I need to balance the equation. Divide this side by negative 2. So you always notice the way when I choose to do something, I need to write it twice to balance. So negative 8, negative 8, negative 2, negative 2. And if we look up above, add 7, multiply by 3, multiply by 3. Okay, so if I negative 2 fits into negative 2 once, so that's it. Awesome, I'm just left with x here on this right-hand side now. And 9 divided by negative 2, well, this answer is a fraction. You can leave it as improper fraction like this. Perhaps it's better to turn it into a decimal. 2 fits into 9 4.5 times, but it would be negative 4.5 because the whole fraction is negative. Or you can write it negative 4.5 if you want, either as x, or you can write it as negative 9 over 2, the whole fraction negative. All these answers are correct. That's correct, that's correct, that's correct, that's correct. They're all correct. It's all the same number. That's a point in here. You can't see it. Okay, so they're not going to get any more difficult than this one today. That'll be about as hard as it gets. Okay. So no one quite got that one before I got there, but that's okay. As long as you now perhaps are getting into the method, that's great. We're going to be doing this for the next 2 weeks. So if the method didn't quite stick today, have a go with it. I'll put up this video again for you, and I put up another video I did with a class last year. You can check that out as well. But there's a worksheet today, and let me just show you it. So I'll just change screens for a second. Okay, I'm on this screen now, so hopefully if you pinned, you need to stop. Okay, and this is you guys, this is your new worksheet. Okay, so solving 1 and 2 steps. The method is key. Now it's so key, in fact, that I put the answers at the end. So there's extra answers down here at the end, but the only questions I ask are question 1, 2, and 7. So you just need to do 1, 2, 7. I've left out 3, 4, 5, 6 in the questions. So they're so key, the method is, that I give you the answers. So you can check your answer, but it's the method that is key. So although, for instance, this first one, perhaps, you know that, well, something plus 7 is 15. You know the answer is 8, but practice the method. You must write the method, and that's what I'll be looking for when I see you guys. Hopefully I see most of you tomorrow on campus. That'd be great if you can come in. Yeah, so I think we're back to being mostly on campus from tomorrow. So this is not due to be finished for tomorrow, but I would like to see it started for tomorrow, and some at least do 3 or 4 questions. So green have to do all of this first question. That's all they have to do. Yellow, do the first column from each question. So this column, the first column straight down, first column straight down. And blue, the last column of question 2. So this column, you see, they can start get a little bit tricky here. And then the last 2 columns of question 7.
So that's that column and that column. Hopefully that makes sense to you all. So you can choose what one to do. So stop sharing for a second. Again, I just want to make sure you are there. So I'm just going to take the roll audibly. So when you hear your name, get ready to say that you are here. Just stop the recording first.